Now we're going to get started on liquids. Liquids, I've got some water in this container here. I've just added a bit of food dye to give it some visual contrast so you can see which jar I've poured it into, because our background here is white and I'm dressed in white as well. But you can imagine this as a good representation of most liquids that you're familiar with, like milk and water and you know, all kinds of things, alcohol. Hopefully not alcohol as a Year 8 student, but you may have seen alcohol on a shelf. So what can we say about its physical properties? Well, the main feature about liquids is that they can be poured from one container into another. So I'm just going to pour this across. Now you can see that I just filled this to 100 milliliters, and this has also been filled to 100 milliliters when I moved it across. Do liquids have a defined shape? Not really, because they take the shape of the container they're poured into. So when it was in this container, it was definitely in a very cylindrical shape. But when I poured it into this one, now it's a bit shaped more like a cone. It takes the shape of its container. So if I pour this into a teapot, it'll be shaped like a teapot. So it doesn't have a defined shape at all. So I should correct my table here. It does not have a defined shape, not a fixed shape. Does it have a defined volume? Absolutely. You just saw that I poured it from this container to this container. This one here had all the way filled up to the 100 ml mark. And this one here is also showing it's been filled up to 100 ml mark, even if I've moved it into a different container. So yes, liquids do have a defined volume. So I should give this one a tick in our table. Are liquids compressible? Well, actually, no, they don't compress. And this is a feature that we happen to use to our advantage in the real world, where you may have seen like machinery which is used to dig up the earth and move it around, and they have these mechanical arms and limbs. Those ones are actually driven by pipes, which we call hydraulics, which are actually being pumped in with a liquid to let the tube expand. And that enables the machinery to actually move its limbs. It's because of that feature where if we could pump in some oil into those hydraulic parts, you can actually push and move the machinery with a lot of strength because it won't compress. So liquids are non-compressible. And let's move on to our next state of matter, which is gas.